Okay, hello class. So this is a recap of what we covered in class today. So what example 1 shows a solid figure formed by identical cubes. Sketch the 2D view when the object is viewed from the top, left, right, front. Now I actually went ahead and used this software to recreate this 3D solid, right? So now they say this is the top view, right? So let's look at the top view of this 3D solid. So you will realize that the top view look like this, right, which is exactly what we drew here. Okay, then the front view, right, the front view they say is here. The front view is here. Okay, so when you look at it from the front view, right, you realize it looks like this, right, this. Then they said look from the left is the side. Okay, so we rotate it this way. Okay, then we look at it from this side. Okay, so we realize it's an L shape, right, as shown here. And then we look at it from the reverse side. All right, the reverse side will be here. Oops. All right, the reverse side will be here. So we look at it from the front, and then you realize it looks like this. Okay. All right, so this is how we get our answer. So make sure you draw using your ruler. Okay, so when they talk about the net of the cube and cuboid, okay, you imagine like you're opening a box and you're flattening it. Okay, so you realize that this cuboid should have 6 faces because there are 6 sides to a cuboid. Same for a cube. Okay, now so for this one, let's say we want to understand how does the net of a prism looks like. Okay, some of you may be quite unsure. Right, so in class we already have this diagram. Okay, we already have this diagram. Alright, okay, then you follow the scaling. So down here should be around 2 cm, 2 cm, 4 cm. Okay, but how does the 3D model looks like? Okay, so I actually created one here, but I had to recreate the whole thing piece by piece. So let's say you have this triangle model here, right? Then I want to know how does it look like if I open it up. Okay, so from here we can actually do this. Okay, this tends to lag a bit because there's too many shapes here. Okay, so from here we can actually open this up. Alright, we can actually open this up. Alright, so if I open it up so it's flat, right, and I move it here, okay, it's not perfect, okay, so to avoid too much time spent, okay, I'm going to open it up here. Okay, flatten the thing. So you realize this is the side. Okay, I'm going to open this up here. From here, I'm going to open up here. Okay, shift it here. And do the same for the other side. Okay, oops, there's a duplicate. Okay. Hang on. Okay, then finally this side I open up. Okay, so piece by piece I open this up. Right, so can you see that it resembles what we have on that page just now? Okay, a little tight here. Okay, if I arrange this properly after opening up. Alright, so you see because the triangle is 3 equal sides, right? So the 3 rectangles that we unfolded are also equal in length, right? Can you see? Right, so we actually have the same shape when we unfold it, right? When we unfolded it from the trapezium. Okay, I'm gonna lower this. Alright. Same for here. And same for here. Right? Okay. Right. Okay, so hope this makes it easier for you all to envision why the trapezium unfolds into such a way. Okay. So next one we have your trapezium prism, right? Trapezium prism. Okay, so I have the net here actually. Right, I've already created a net. So what we're going to do is we're going to do the reverse. We're going to fold it in. Okay, we're going to fold this in. Let me move this out of the way first. Okay, we're going to fold this in. So we'll fold it in. Oops. Alright, so it's standing up. Alright, we're going to fold it in. Going to do the same for this one. Alright. I'm going to move it into. So here. Okay, then we'll pull it up. Okay, right, so we have the sides. Okay, oops. Okay, a bit hard to arrange it nicely. Okay, if you want to try this software on your own, you can. It's free, you just need to register. Okay, anyway, you don't have to get exact, just to show only. Okay, then we're gonna move this up. Okay, so this forms the back. Right, so you can see this forms the back. Hard to get a rotation. Okay, so here forms the back. Okay, then from here this is actually the top, right? This is the top. Okay, which is why it flips out that way. And this one, okay, this is going to be a challenge, but this one we actually rotate it this way. Okay, don't think I can get exact. Okay, maybe rotate a bit more from this side. Okay, looks like it. Then we're gonna slide it in here. Okay, so you see this is almost our, this is almost the same kind of prism that we see in our question, right? So you can see how it folds out and folds back in. Okay, so hopefully this helps you to envision why this trapezium prism folds out to this shape here. Okay, you can do a rough drawing, you can follow what we saw, right? Or you can just create the same thing and try out the software yourself. Okay, now volume of prism, right? Why is it that this is area of triangle, right? Why is it this is the area of triangle multiplied by your length here, right? Why is it multiplied by your length here? It's because in order to get the prism, okay, we'll go back here. In order to get a prism, right? You realize that it's just moving your, right? It is just moving your, right? So if I show you this one, okay, your volume actually just comes from you having a basic shape. So right now this is 2D, right? This is 2D. This is a triangle, right? And if I find the area, I want to get the volume, right? All I have to do is just lengthen, right? And so can you see, right? From 2D to 3D, right? What makes the difference between 2D to 3D? Right, you go from a 2D shape, you add another measure of length, right? It becomes volume, right? So that's why the formula of your prism is always your base area, right? Here is a triangle, multiplied by your length to get your volume, right? So when we go back to here, this triangle here, right? The formula for triangle, what's the area of formula of triangle? Area of triangle, half times base times height. Okay, please go and memorize this. Your base is 10, your height is 7. Half times 7 times 10 times this one, right? So this is area of triangle. This is your length. You will get your volume. Okay, same for here actually. Right, same for here. So okay, this part is getting a bit cluttered. Okay, but there's space here. So what happens is, if let's say I create the same figure, it's two squares, right? So I have this one, this is one cuboid, and then I mimic it. Okay, I shrink it down, okay, I shrink it down, and then I put it next to it. Right, so do you see it's actually the same thing? If I select the two of them together, right, and I actually move this here, here, do you see that when it goes and become a basic shape, it's just two squares, the 2D form, right? Then 3D, palm times length, 2D, right? Volume, palm times length, 2D, palm times length, become volume, right? So it's very easy to see with this software. So this software is great. I just found it today. Okay, so from here, you will notice that to find the area, the volume, you need to find this area here, right? This is why you need to find these two areas here. Okay, so this is 2 times 2. This is 1 times 1. Right, so which is why 2 times 2 plus 1 times 1 to get this whole area here. Right, then you times the length, which is 20. Okay, can? Then you times the length, which is 20. Right. Okay, so what example 6? Same thing. We go back to our diagram. Okay, getting a bit cluttered here, so I'm going to delete this. Okay, so I'm going to copy this shape here because easier to just copy. Okay, so again, this is our 2D, right? And then, oops, let's see if I can get that. Okay, this is our 2D. I think let's make it flat first. Okay, so it's flat now, right? Put it on the ground. Okay, so if I want 3D, oops. If I want 3D, basically I am taking this and, oh, it's moving. Okay, so sorry. Okay, I'm just gonna recreate this thing. Down, right. Then I'm taking this here. Here, this way. Okay, then down as well. Okay, so I'm gonna overlay this. Same height. I'm gonna bring it up so it overlays. Okay, so combine union this way. Right. Okay, so we have this. So now I'm gonna make it solid. I want to create the volume. See? Can you see? I can create the volume. So all I need is the 2D shape first times the length to get the volume. 2D shape times the length to get the volume. 2D shape times the length to get the volume. Okay, so the same thing here. I need to find area of trapezium. Alright, so write this down. Area of trapezium. Alright. Half times the two parallel lengths A plus B multiplied by the perpendicular height. Okay, multiplied by the perpendicular height. Alright. Okay, so now, so this is why I find the area of trapezium, which is half times 1 plus 2. This is 1 plus 2. Okay, this is 1 plus 2. Alright, so area of trapezium, half times 1 plus 2 times 50. Okay, area of trapezium multiplied by 23, right, which is the height here, okay, which is the length here, right, the height of the block from this angle. Okay, the last one, okay, a bit harder to explain because it involves water in this container. So right now we have something like this. Okay, I'm gonna delete this. Okay, we have something like this. Alright, so hopefully after a while you get to see and understand how this looks like. From here, okay, your you have a trapezium, right? Because your water level is up to a certain length, right? So your water level, going to be hard to do this. Okay, make a smaller version. Okay, so let's see if this works. Okay, we'll color this different. Okay, let's color it. Okay, let's color the big one blue. Alright, then this one we'll color it green. Okay, so I'm gonna put it out a bit. Move on the side. Okay, I'm gonna stand this all the way. Alright, so you can see that from here there is a trapezium. Alright, not sure if I can write on this. You can see that from here there is actually a trapezium. Alright, can you see the light blue trapezium shape? You look at it from here. Alright, ignore the green. Okay, or maybe I turn this invisible. Okay, so you can see this light blue trapezium shape here. Okay, never mind. Dark blue maybe works. No? Okay, you can see this light blue trapezium shape here. Let's just move it up a bit. Just a bit. Okay, so you can see this trapezium here at this bottom that's light blue. This is the water. This represents the water in the trapezium. Right, so it's at this level now. Okay, so but what happens if I rotate the whole thing? Okay, I rotate the whole thing this way. Right, now I rotate the whole thing this way. So by right, if you can imagine this, because the software cannot portray water moving. Okay, so once you rotate it this way, all the water will flow down. Right, all the water will flow down. So that means this triangle actually gets lower. This triangle actually gets lower. Okay, and never mind. Okay, so when you look at it this way, the water level actually now conforms to show this triangle. Right, so there's no trapezium anymore. So we use the trapezium to find the volume of water in this figure 1. Right, so the formula, find area of the trapezium times the length. Right now I think you should understand, to get a volume. So from this volume, when you turn it over the other way, when it's standing up in figure 2, okay, the water falls back, and now the water forms this triangular face instead of the trapezium. But because now the base area, the 2D shape has become a triangle, your length here, right, your length here will be different from your length here. It's not the same. Right, so what happens is you need to take the volume of water, because the volume of water in both figures are the same, divide by the triangular shape, which is half times 7 times 10. Then you'll find out that the height is 7.5 cm. Okay, so hopefully this is helpful to understand with the use of the 3D software. I'll be trying to use it in further explanations for the other work examples as well. Right, let me know what you think of the 3D software, whether it's helpful.